Welcome to Reimagine Mobility podcast series. I'm here with Thomas Wallner from Argonne National Lab. Thomas, thanks for joining us today, and thanks for, together with us here, help us reimagine mobility, certainly with your experience in this space and what you guys are doing at Argonne. So maybe to start out with, tell us a little bit what your responsibility is, but then certainly tell us, what is Argonne doing? Because everybody knows about Argonne, but I think there's a lot of people who are like, I don't really know exactly what they're doing, what their purpose is. So maybe we'll start out with that, and then let's jump into really what your purpose is to help us all in this industry reimagine mobility.
All right. Well, first off, thank you for the opportunity to speak with you. I'm always excited to share some about the work we do here at Argonne. So for those of you who don't know Argonne National Lab, we are a government-owned contract-operated facility outside of Chicago, about 3,500 employees, and we have an Applied Energy Technologies Directorate that's specifically focused, as the title suggests, on addressing some of the challenges we have on the applied engineering side. Our main focus is really to help with the transition to a decarbonized economy. And in my division, which is the Transportation and Power Systems division, our focus is really on anything related to mobility, moving people, moving goods, and also in terms of how would we potentially generate electricity, or how else could we store that electricity to then eventually use it for mobility applications. So it's a pretty broad portfolio. The team here is about 140 people. We have sizable experimental facilities for vehicle testing, component testing. They go hand in hand with simulation activities that we have here, where we simulate everything from the component to the system level. And then even on the regional level, we have an agent-based simulation tool that simulates, for example, the entire Chicago regional area. One aspect that's probably also unique for us here at Argonne is we have traditionally been engaged in workforce development. We have a student competition that's quite well established that Argonne has been managing for Department of Energy for probably 30 years. And so we also try to bridge this gap as we transition into this new electrified reality. How can we help transition the workforce to have new opportunities in that space as well?
Very good. Thank you. Perfect. So let's jump right in. It's like within the year, everybody in the U.S. and globally also talks about the IRA, the Inflation Reduction Act, where a lot of some of the things you touched upon has come in, certainly maybe more on the manufacturing side. But as of late, we're now also talking about how do we get let's call it the users of this new energy, hydrogen, battery electric vehicles also encouraged. So not necessarily the manufacturer, but also the users. Where is Argonne involved with this? I mean, how do you help not only the manufacturing side of batteries, fuel cells, hydrogen generation, but also then the user side to really adopt it and make consumers like us drive these types of vehicles? And where do you see how you help with that transition?
So I think we're quite broadly involved in this. As you suggested, it starts really on the fundamental side, where we have traditionally done a lot of research on the technical solutions. And those include electrified powertrains for light-duty, medium, and heavy-duty vehicles. Nowadays, we're working more on even decarbonizing rail, marine, aviation, and some of those other modes. So that's more on the technical solution side. We've also have a very large footprint in the analysis side. I already spoke about the simulation that in some cases goes hand in hand with the component development, but we also do analysis. You mentioned, for example, IRA. We're doing analysis in terms of what are some of the financial incentives. We also do work with the Joint Office of Energy and Transportation when you think about the rollout of electric vehicle charging stations and considerations as to what might be an appropriate location based on technical requirements, based on maybe available grid infrastructure, but certainly also always with an eye on environmental justice and equity. So we have a separate team outside of my division that specifically looks at those aspects to make sure that rollout of an electric infrastructure is equitable for the entire society.
Interesting. So let's stay for a moment with the electrical charging infrastructure. I'm a new proud owner of a first electric vehicle for the family. And I think, at least between my wife and I, we were a little bit worried or a little unsure about different things about owning an electric vehicle. Charging certainly is the common denominator. What do you see as the next step that we as a nation, or maybe you as Argonne, or we as from the supply side, or maybe the OEMs should be taken or should be more focused on to overcome some of that hesitation? And again, the reason I'm bringing it up is I've been working in this space for 10 plus years, yet I'm considering myself very similar to maybe non-automotive or automotive technology-based people that also have maybe even larger concerns because we're not constantly hearing what's going on and what other people are doing. So what do you see, and what is the government sort of tasking you guys with doing?
Well, first off, congratulations for taking that big step of having an electric vehicle in your fleet. My family also has an electric car, and I agree that at first that transition might seem scary or intimidating because you hear about range anxiety as one of the examples. Where Argonne is specifically involved in here there is various aspects. One very important aspect right now is reliability of charging, especially when it comes to DC fast charging. There is information out there, and depending on which source you want to believe, there is a significant fraction of the attempted electric vehicle charging events that are unsuccessful. And I always remind everyone in a conversation that the benchmark that we come from is conventional vehicles. And do you remember the last time you went to a gas station and left without gasoline? I honestly don't. So the success rate in terms of refueling is very high. And that's the benchmark we have to consider when we think of electric vehicle charging. That's what we strive towards. That's a major focus for the joint office, as I had mentioned. And our teams here in the grid integration technology side are heavily involved in this standards-based communication between vehicle and the charger. The standards exist, but there is certainly a lot of work to do in terms of developing performance indicators, refining the standards to ensure that this expectation that the consumer has in terms of success rate is something that we can meet. Another important aspect outside of DC charging, which in an ideal electrified future would be not the norm for everyone. We can suggest that every charging event is a DC charging event. Predominantly, vehicles should be AC charged at home, at a workplace, or elsewhere where you might be dwelling for an extended period of time. And what's important there is that we consider how do we reach the entire population with AC charging. You and I are probably fortunate that we have dedicated parking where we have EV charging available, right? But that is only true for about half the population. So how do we ensure equitable charging for people that don't have a dedicated parking spot? So there is some interesting conversations going on with curbside charging as one example, or other opportunities on how to ensure that people have access to charging when they need it. Another very important factor is really changing almost like a paradigm shift in terms of how we think about refueling versus recharging, right? It sounds so similar. So the initial anticipation is, well, it's the same thing. When my tank is empty, I go to the gas station. When my electric vehicle is low on charge, I'll go and recharge. But in reality, because of the distributed charging that we're advocating for, that might not be the case, and your vehicle during regular operation might never drop below, let's say, 50% state of charge, because maybe your daily driving is such that you plug in at night and you always top off the vehicle. There's another important factor when you consider that, because right now we're very concerned about electric vehicles as an additional drag on the grid, which could be a concern. But if we think of a future where electric vehicles are connected to the grid, whether they need a charge at this point in time or not, then all those distributed batteries could be leveraged as a resource, and they might be able to actually help stabilize the grid and provide services. So those are some of the areas we're looking into. At a high level, that all sounds great, but you can imagine that there is a lot of details that need to be worked out, questions in terms of warranty, revenue sharing, what are the communication standards, and those are all topics that our team is involved with partners at other national laboratories and in industry.
Interesting, very interesting. You alluded, Thomas, at the beginning a little bit that you're not just doing passenger vehicles and heavy-duty truck, right? But you mentioned rail, you talked marine. I assume maybe eVTOL, so electrical airplanes maybe is something you're involved as well. Share a little bit there, because I think that is sort of the next frontier now that has sort of, in my opinion at least, adopted the electromobility or electrification push. And then certainly they're also, with other industries as well, certainly heavy duty, the hydrogen or fuel cell based. But share a little bit about those industry maybes, again, outside of what you and I see on a daily basis, which is medium and heavy duty trucks and obviously the personal vehicles we drive. What are those other industries doing, right? Construction, marine, rail, etc.
Yes, so historically there was a lot of focus on light duty vehicles. The main reason is an obvious one, that's a majority of the energy consumed for transportation is in the light duty sector. But for light duty, with electrification, we have a very workable solution, as we see with significant uptake in terms of electric vehicles in the market. As we look at applications that are higher in power, longer daily driving, or just higher energy density requirements, the all-electric option might not be the ideal option. There was a release of a decarbonization roadmap from the U.S. government fairly recently, where they really laid that out quite well in terms of what are the options we should consider. And you spoke about medium heavy-duty trucking, right? Electrification might be the right answer for some of those vocations. If we think of long-haul trucking, maybe there's other options we need to look into, like hydrogen and fuel cells. And then when we get into other applications, we refer to them as DORMA. There's actually an office in the Vehicle Technologies Office at the U.S. Department of Energy. This acronym is DORMA, Decarbonization of Rail, Marine, and Aviation. Right? And when you think of those applications, direct electrification seems to be a much less likely answer. We might still be able to use renewable electricity, but how we store that for those applications might be very different. For aviation, for example, sustainable aviation fuels seem to be the path that the industry is embarking on. If we think of rail and marine, I think the answer is still somewhat open as to what might be the right application. Hydrogen and fuel cell come to mind. Maybe other ways of storing hydrogen that could be ammonia or methanol or some other chemical way of storing hydrogen. And fortunately, here at Argonne, we have a long history on working in large engines. We have locomotive-sized engines here on site, and so we have spent several decades working in that area, and we can leverage some of those resources to really try and identify some of the answers that are needed for those applications.
Interesting. So let's sting a little bit with this, and let's say we go back 5 years and what you were at Argonne doing then, and compare that with what you're going to see over the next 5 years. What are the biggest changes you have observed and are going to observe when you look into the future as we reimagine mobility? Is it the tools that you have at your disposal at Argonne to do your research and do your testing and do an analysis? Is it the equipment? Is it simulation technology that certainly has come a long way from 5 years ago and is going to continue with the addition of AI the next 5 years? Is it the technology that comes out of the economy or from the OEMs, from all those different players we just talked about? Or you share with us, what do you see? What's the big change that you have experienced?
So from an application standpoint, I think we already spoke to some extent about that. We have really transitioned from traditionally having worked in light duty space and now much more focused on the medium heavy duty and some off-road as we spoke about. The other aspect I think that at a high level that has changed is we used to look at individual solutions, right? You could be an automotive expert and be happy for an entire career with your blinders on and maybe not look too much left or right. And I think with thinking of all the alternatives we're looking at right now, that is not the right path forward. So the term that we're using here really is systems of systems considerations. And the best example here is electrified mobility, right? We can't just look at that in isolation, because if we put additional load on the grid, well, how does that impact the grid? And what opportunities do we have by doing this in a smart way versus in an unmanaged way. Electric vehicles in the grid is just one of those examples. If we think of hydrogen, right? Now we have to think of a new refueling infrastructure. What would a build out of that look like? And you could go on and on in terms of the examples of how systems that we previously considered separate are now being connected. And the way we approach it here at Argonne is really from a consumer needs and desire standpoint, because ultimately what we have to deliver is not the perfect technical solution, but it's a solution that customers are looking to embrace. And they are choosing modes because of individual preferences and certain constraints they might have. And the treating them as one homogeneous block isn't the right way. It's not the right way for light duty application, and it's certainly not the right way when we think of other applications, right? Typically, we refer to some of those larger applications as hard to decarbonize, which might generally be true, but some of them are much easier to decarbonize than others. And the answer, yet again, lies into a system analysis where depending on where you're located, what resources you might be available, hydrogen might be the right answer, or electrification might be the right answer. So in general, I think over the last 5 years, we started to just widen our aperture in terms of what do we need to consider to come up with the right answer versus just deep diving into technical solutions. So I think that was probably the biggest change that we see here. And as you mentioned, improved computational resources certainly play into that. AI is playing into this as well. But at a high level, it has allowed us to look at those systems of systems in a more integrated way.
Yeah. It's interesting you bringing up systems of systems, because we have certainly seen at AVL of the last, I would say, 3+ years, a consistent increase in importance and staffing as well that we need for systems engineers, right? Where before we all sort of created our own Lego blocks and then assumed they all came together. Today, we sort of start with the systems guy that then decides what the Lego blocks are before we design them, and then come all together and put them together. So very appropriate there. Let's jump in on some of the mega trends, right? So besides electrification, really, or the decarbonization trend or push that you are heavily involved with Argonne, and we as well, we see obviously many other mega trends in the automotive space or in the mobility space. One certainly is, again, the emergence of AI in all the different places it can be used. And I think in many places it's already used today, at least to some degree. We don't even recognize that it's truly AI. The other one clearly is ADAS, or autonomous driving, right? And whereas a few years ago, level 2 was like the thing we all pushed for, now it's level 2+ and level 3 that we're really getting to. And I think we're still a little bit or several years out from truly level 4, level 5. But how does these other two mega trends, again, AI on one side and let's just say autonomous driving, so level 4, level 5, how do those two tie into what you guys are doing at Argonne?
When it comes to ADAS and ADS, automated driving features, that's another area that over the last 5 years we have engaged heavily. Being a national laboratory, our Department of Energy National Laboratory, our focus is actually quite different from what's very frequently discussed, and that is the safety aspects, right? When you think of connected automated vehicles, you think of edge cases that might be of concern, and of course we all know news stories that support that. Our interest from an energy standpoint is quite at the other end of the spectrum, and I always call these the boring, mundane cases, but the ones that happen over and over again during a day. And if you think from an energy point of view, those are the ones, if you do those well in an energy efficient way, that's where the energy savings are. So we are focusing on this niche to some extent, while everybody else is focusing on the safety aspects. We're looking at where are opportunities for energy savings with connected and automated vehicles. We have done a lot of analysis, but also some experimental work. Some examples just to highlight here, we operate production connected and automated vehicles. We have developed our own sensor array, and what we are interested in is how does an automated vehicle impact traffic around itself, around the ego vehicle? The ego vehicle might be operating very fuel efficient, but if it upsets traffic flow, then overall we might see an increased energy consumption. That's an aspect we're interested in. And then going back again to the systems of systems perspective, another aspect that's very important with connectivity and automation is how are people going to use it? There's some very interesting studies out there that suggest that we might see more vehicle miles traveled, because if I don't have to do the driving myself, I might be willing to accept a longer commute, or things I would have otherwise done with rail or flying or some other mode of transportation, I'm willing to drive now. And how that might have a negative impact on the overall energy consumption, that is another area that we're quite interested in. I think the jury is still out. As you're well aware, the full automation is still a couple years out, as you had mentioned. And that's going to be very interesting in terms of how people are engaging with the system, because that could have much larger energy implications than building the perfect system. And yet again, that's where sort of like this human behavior aspect comes in, that as an engineer, I never thought that would be a major concern for our engineering teams to understand how people might engage with the system.
Okay. If OEMs or suppliers are listening to this, Thomas, how can they get a hold of you guys to try and benefit from some of those studies and testing you can do, or studies you do for the government, to, again, improve the technology and sort of future-proof their vehicles or their designs, that it's not just good for the next year or two, but really something that hopefully is much more future-proof? We all know there's nothing that is 100% future-proof, but can use this to better their products. Is there a way to get a hold of you? Is there the best way to get information from you? What would that be?
So we are quite engaged. Being the applied side of Argonne National Laboratory, we're quite engaged with industry. We're part of many consortia, and I would encourage anyone that works in this space to either contact us, and we can point you in the right direction. Some areas that come to mind is we're in consortia that are looking at improving the reliability of electric vehicle charging. There's a Joint Office ChargeX consortium that's worth highlighting. Also, since we spoke about connected and automated vehicles, one topic we are engaged in with SAE standards communities now is how would you test a fully autonomous vehicle for fuel economy? I mean, maybe following a drive cycle doesn't make any sense at that point because the vehicle is making driving decisions. So these kinds of forward-looking questions is what we are interested in, and we encourage industrial players and others that are interested in that space to engage with us and engage especially with the standards bodies, because as you know, they typically move slowly in many cases, not in all, and we need to get ahead so when those technologies are coming out, that the standards are ready to really evaluate them too.
That's great. It's a perfect fit for what we're talking here, how we reimagine mobility. Thomas, this has been great. Final question for you. What's going to be your next vehicle you're going to buy, and why?
That's a tough one. I mentioned that our family has an electric vehicle, and actually what we purchased was an 8-year-old electric vehicle. So we were that customer that takes the risk of buying a vehicle that's out of warranty. But knock on wood, it has been treating us quite well. We enjoy the quiet acceleration. I have young kids, so they enjoy the quiet mode of operation. Right now, what I might be looking for is fully electric vehicles that can accommodate a growing family. Plus, maybe, some of the toys and bicycles and everything else. We see some of those vehicles coming out, and that's something I'm particularly excited about, because the more we build out options for any individual situation, I think the more uptake we'll see of those vehicles as well.
Very good. Would maybe to add one more last question, subsection A, would a hybrid fall into this for you? Or are you like, no, I'm more of a pure EV kind of guy?
I'm personally really open to the hybrid and plug-in hybrid option as well. especially since we are in the Chicago area, we have family in Michigan, and so that we do this drive on a regular basis. But for most of the day-to-day driving, we don't need the big battery, right? So maybe a plug-in hybrid might be a logical solution to keep vehicle weight and keep costs down, but still for the daily driving, still be able to take advantage of electric mobility. So certainly something that's on our radar.
Very good. Perfect. Thomas, thank you so much for your time, and thank you so much for sharing what you and Argonne National Lab is doing to reimagine mobility here and for many different applications in the U.S. Thank you so much.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.